Hello. In this problem set, I'll be talking about an article called Association Between Temperature, Humidity, and COVID-19 Outbreaks in Bangladesh, published by the Environmental Science and Policy Journal in December 2020. The key focus of the study is COVID-19 in Bangladesh. The data was collected by the Institute of Epidemiology, Disease and Control Research Center, where they collected the daily nationwide COVID test cases. Temperature and humidity were collected by the Bangladesh Meteorological Department. The sample data seems to be the 9,455 test cases ranging from an interval of March 8th until May 3rd, 2020. There are 4 variables of interest: the number of test cases per day, number of positive test cases per day, temperature, and humidity. There is one variable the study doesn't consider but has brought up. There are the tropical and temperate countries. It is clearly stated in the study that the testing frequency, accuracy, and the death rate are different from the temperate countries to tropical countries. We can see the relations over here. This could be an influencing factor of transmission and spread of the virus, but will not be considered in the research because of limitations in the data to start with. By looking at the associations and relations with the key important variables, the research question comes down to: do warmer and humid weather slow the spread of COVID virus in tropical countries? This research question could be analyzed with multiple linear regression as shown below with the equations and the terms of each listed. For analysis, there were 3 visualizations with the corresponding data: summary tables, histograms, and summary table of coefficients. For summary tables, they summarize the average number of test cases and positive test cases per day, and the range of average temperatures and humidities with respect to our variables of interest. For histograms, there are 2 histograms faceted vertically, visualizing the distribution between number of cases on the y-axis and temperature on the x-axis, or humidity. Both the histograms show a right skew, and this could possibly be explained by the negative correlation between the number of COVID cases with respect to temperature and humidity. The summary table of coefficients show us the association between average temperature and humidity with daily confirmed COVID cases. The slopes for temperature and humidity were both negative, with p-values indicating moderate to strong evidence against the null hypothesis that there is no relationship between the temperature and humidity with the number of test cases. For our independent variables of virus transmission, there are 3 possible influencers: aerosol, stability of virus, and infections and immunity. Aerosols are little droplets floating in the atmosphere, and in this case, viruses. They are influenced by humidity, and for example, in a dry atmosphere, droplets stay airborne longer and are more freely moving. Thus, the transmission rate goes up. Virus stability are referring to how long the virus can survive and remain potent. They are related to temperature. Influenza viruses are more stable at colder temperatures. Infections and immunity, they are related to both humidity and temperature. The colder the temperature, the lower the immune system, and the drier the weather, the drier the respiratory tracts of people are, which both contribute to more vulnerability to these viruses. By having the statistical analysis, we could say that there are relations between temperature and humidity with the number of cases which quantify transmission. Although the study shows that higher temperature and humidity lowers transmissions and the number of reported cases, there are many aspects to consider, such as the proportion of the population already infected and how those viruses will spread until the arrival of the tropical seasons in Bangladesh. In other words, the future is unknown and random. There needs active interventions such as social distancing for minimizing the spread of the virus. This is all for my presentation, and thank you very much.